Units. Everyone uses them, but where do they come from? And why are they important? Before we take about units, let's take a step back and start with dimensions. When you hear the word dimension, you probably think of distances, maybe something being 2D or 3D. Dimension in science is a broader concept. A dimension is an expression for a measurable, physical quantity. If you can measure it, it has dimension. And no matter what you use to make or report that measurement, it will always have the same dimension. In all unit systems, there are 7 base dimensions. For now, let's focus on 3 of them: mass, length, and time. Or, as an abbreviation, M, L, and T. All other dimensions, speed, force, acceleration, energy, are obtained by algebraically combining these base dimensions. For example, the dimension of speed is length per time. So all scientists agree upon these dimensions and these definitions for the other derived dimensions as justified by physical laws and equations. But what are we going to do to make the actual measurements? And once we make that measurement, how can we communicate a standard amount of that dimension? Unit systems were invented to do just this job. In our class, we will focus on the SI unit system. Originating in France during the 1790s, started as the metric system during the French Revolution, the SI unit system is the lingua franca of measurements for scientists around the world. The original definitions of the units in the SI system were physical objects, but have since been defined by reproducible experiments, except for the kilogram for now. So what are they? Let's start with the meter. 1 meter is about 39 inches. A typical person is between 1.5 and 2 meters, and your physics textbook is about 0.3 meters. The meter is abbreviated with the lowercase letter m. Next, we have the kilogram. The kilogram is a unit of mass. 1 kilogram is about equal to 2.2 pounds. A typical person is between 80 and 100 kilograms. Your physics textbook is about 2 kilograms. The kilogram is abbreviated kg. Well, why isn't the SI base unit the gram? Well, it just has to do with history, and that 1 gram is not a large amount. I'll link to a video with the rest of the story. It would be like measuring your height in millimeters. And finally, the second. The second is a unit of time. And sure, you know how long 1 second is, but did you know that there is pi times 10 to the 7 seconds in 1 year? Random neat fact. But wait, what's the big deal about units? Why do they even matter? Units are about clear communication. What if I told you owed me 5, and I meant dollars, but you gave me cookies? I might be disappointed. Likewise, we need our units to be standardized. If my meter is a different amount of length than your meter, we can't share our measurements. And if we can't show our measurements, then we can't independently verify our experiments. Every time you report a number, you must include a unit. Numbers without units will not receive full credit on a quiz or exam. Next time, we'll talk about how to convert units. As always, thanks for watching.